Okay, we have completed these reactions. These are of acid and metal oxide. Did we completed this, or we have completed acid with metals?
Sir, we also did acid and metals also.
Sorry.
We
Can
did
you-
acid and metals also.
Okay. Okay. And are we done with these observations as well?
Yes.
Yes.
Yes, sir. The last heading was test for hydrogen. We did.
Yes. Can you repeat now, Khatija?
Sir, the last heading which we did was the test for hydrogen. Yes, still here. Above.
Okay, over here. Okay.
Yes.
So I'm going to share this file as well. So we are done with the reactions of acid and metals in the last class. Now, there are basically two kinds of reactions of acids with a base. Firstly, when acid reacts with a base, we called it a neutralization reaction, and normally what we get salt and water. This equation we already done in the previous classes. There are two kinds of bases. One are the bases which are metal oxides and metal hydroxide. And when metal oxide and metal hydroxide reacts with acid, we always get salt and water. But when an acid reacts with the aqueous ammonia, when acid reacts with the aqueous ammonia, we only get salt, and all of these salts contains ammonium ion in them. Okay, so there are two kinds of acid-base reaction. One is when acid is reacting with metal oxide and metal hydroxide. In this case, we always get salt and water. But when acid reacts with only aqueous ammonia, then we always get ammonium salt. And here are the reactions of acids with most common acids with the ammonia. So if you see, when hydrochloric acid reacts with aqueous ammonia, ammonium chloride is formed with the formula of NH4Cl. When nitric acid reacts with aqueous ammonia, ammonium nitrate is formed, NH4NO3. Okay, in both of these cases, if you see, ammonium ion have a +1 charge, chloride have a -1 charge, and NO3 have a -1 charge. So +1 and -1, that's why we just combined it to make the formula. In the same way, if you look over here, it's NH4NO3. NH4 have a +1 charge and NO3 have a -1 charge. So we just combine them because the value of the charge are exactly the same. Now, in the third case, when sulfuric acid reacts with ammonia, we get ammonium ion, and the salt formed is ammonium sulfate. But in this case, if you see, ammonium is +1 and sulfate is -2, right? So when, if you recall from bonding, when we have a different charges on the ions, then to make the formula, we shift the value of the charge on the subscript of the other ion. So that's why when we are going to write the formula, it will become NH4 in closing bracket, and then we write 2 because 2 is the charge of the sulfate ion, and then we will write SO4, and there is no need to write any other number because the charge is only +1. So we usually don't write 1. So that's why it becomes NH4 twice SO4. In the same way, when phosphoric acid reacts with aqueous ammonia, now if you see, ammonium ion and phosphate ion PO4, and PO4 have a 3- charge. That's why if you see, I have put it all the ions and their charges at the right side. So now the formula will become NH4 thrice PO4. So you need to remember, when a metal oxide or metal hydroxide is reacting with the acid, the products are salt and water. But when aqueous ammonia reacts with any acid, we always get ammonium salts, no other product. Okay, complete these, then we will continue further. Have you noted down now? Is everyone done? Yes.
Yes, sir.
Okay. Now, after this, we are going to discuss another reaction of our acid, that is acid with metal carbonates. Metal carbonates exist in solid and aqueous both. Solids are the one which are water insoluble, and aqueous are the one which are water soluble. So when acid reacts with a metal carbonate, we always get salt, water, and carbon dioxide. So these three are the products when acid reacts with metal carbonate. And it is very important to remember the formulas of the most common acid, which includes sulfuric acid, hydrochloric acid, nitric acid, ethanoic acid, and phosphoric acid. These 5 acids, you must remember their formulas. Sulfuric acid is H2SO4, nitric acid is HNO3, sulfuric acid is H2SO4, hydrochloric acid is HCl, phosphoric acid is H3PO4, and ethanoic acid is CH3COOH.
The base, aqueous or solid दोनों में सकते हैं.
Yes, the one which are water insoluble, they are usually solids, and the one which are water soluble, we usually use them as aqueous.
But sodium hydroxide तो दोनों हो जाएगा.
Yes. Is everybody done with the green equations? Yes, Manali, are you done?
Sir,
Yes.
how will we know that the metal carbonate is aqueous or solid?
Okay. After completing these reactions, we are going to discuss about the rules for the solubilities of the compounds that you have to remember, and by those rules you can identify if the substance is water soluble, so you always take it as an aqueous, and if it's not water soluble, then you will take it as a solid. Okay. So if you see, which acid is this? It's a hydrochloric acid, and this hydrochloric acid is reacting with calcium carbonate. So calcium carbonate is a metal carbonate. So as we have discussed earlier, a general reaction which indicates that the products will be salt, water, and carbon dioxide. So first what you will do, you will make is leave the salt for initially and make water and carbon dioxide. This is how you can make the correct equation. Okay. So if now you have to identify from where how we will make the salt. But first you have to identify that from or how carbon dioxide and water is being made. So this carbonate turns into carbon dioxide, leaving behind oxygen. Because carbonate, if you see, have a 3 atoms of oxygen, and carbon dioxide have a 2 atoms of oxygen, right? So this carbonate turns into carbon dioxide, leaving behind the oxygen, and that oxygen combines with the hydrogens of acid to form water. So now, if you see, we have marked the ions or the atoms from the reactants which are turning into water and carbon dioxide. So what is left behind on the reactant side?
Calcium and chlorine.
Calcium and chlorine. So calcium is in group 2, so it have a charge of +2, and chlorine is in group 7, so it have a charge of -1. So if the calcium have a +2 charge and chloride have a -1 charge, so what will be the formula of the salt? Cl2, as the 2 of this moves over here, and as we move the 1, so there is no need to write 1 over here. So that's how we make the formula of the salt. Yes, is this clear to all of you?
Sir,
Yes, sir.
Yes, no, that's what I'm going to tell you. Just wait. So first you have to do this thing. You have to make hydrogen and carbon dioxide. After making hydrogen and carbon dioxide, you have to identify the atoms on the reactant side which are forming water and carbon dioxide. And the ions which are left, you have to make the salt from those ions. Now, your question, if you see, there is 1 hydrogen over here and there are 2 hydrogen over here, right? So we do it by balancing. Okay, and the best way of balancing is always start the balancing with the help of salt. So if you see, how many chlorine are here? 2. So I'm going to put a 2 over here. If I put the 2 over here, the chlorine becomes 2 on both the sides. If I put a 2 over here, that makes these hydrogen also 2, right? So if you see, there are 2 hydrogens over here. And if you look at the rest of the elements, all are balanced. There are, if you see, 2 hydrogens over here, 2 hydrogens over here, 2 chlorine over here, 2 chlorine over here, 1 calcium over here, 1 calcium over here, 1 carbon over here, 1 carbon over here, 3 oxygen over here, 1 oxygen is here, and 2 oxygens are here, which makes it 3. So now the whole equation is balanced. Is this clear? Okay. Now, if you have to make the ionic equation, what was the first step?
Breaking the aqueous.
Very good. Just break the aqueous substances into ions and keep the rest as they are. So if you see in this above equation, this is aqueous and this is aqueous. Rest are solid, gas, solid, it's liquid, sorry. Solid, liquid, and gas. So we keep the solid, liquid, and gas as it is, and we are going to split these two aqueous into the ions. So see, we did this. After splitting into the ions, we look for the ions which are same on both sides. So if you see, there is a hydrogen ion over here, but you are not able to see any hydrogen ion over here, right? So it stays in the ionic equation. If you see, there is a chloride ion over here, there is a chloride ion over here as well. So that's why I cut it down. So that is going to be eliminated from the equation. If you see here, there is a calcium ion, but there is no calcium ion over here. So it stays. So I have cancelled out the ion which is on the which is present on the both the sides, and then I rewrite the equation, and that is your ionic equation. So that's how we do the ionic equation. Okay, note this down. Then I'm going to give you a equation. You have to complete that equation and then make the ionic equation from that. Yes, because when it is aqueous, it means it is dissolved in water, and when it gets dissolved in water, the ions are separated from each other. They are not joined with each other in the aqueous state. That's why we split them, and then we cancel the ion which is present on both the sides. Okay. After this is your second equation. You have to complete this equation, balance it, and then make the ionic equation from it. Yes, how many of you completed the equation? Okay, very good. Action. Yes, Manahil, are you done with that? Good, but it's not Ca, it's Cu copper and copper are plus 2 charge. So the formula you make over here is wrong. Good. Now balance the equation. Good. Now try to make the ionic equation. Yes, can you show me? Okay. So why don't you make water and carbon dioxide first, as I have told you below? So if you guys see, as we discussed earlier, we can easily form, we know that when there is a metal carbonate and acid, water and carbon dioxide is always the product. So if you see this, what carbon dioxide and water are formed from these two. So what is left behind? Cu and NO3. Cu have a plus 2 charge and NO3 have a minus 1 charge. So if we will make the formula, it will become CuNO3 twice. Now, if we go for balancing, as there are 2 nitrate ions and 2 hydrogens, so we need to put a 2 over here and the whole equation becomes balanced. Is this clear? Yes, Laiba? Okay. Now, if you look at the states, you can easily identify which ions are going to be cancelled out. As you see, this one is aqueous and this one is aqueous. In both the aqueous, there is a nitrate ion. So when I'm going to write the ionic equation, I will exclude or eliminate this nitrate ion. So if I remove the nitrate ion from the left side, a hydrogen ion is left behind. And on the right side, a copper ion, which is Cu plus 2 ion, is left behind. So see, this will be our ionic equation. Yes, is this clear to all of you?
Yes, sir.
Now try this one. Okay, Khatija. So first make water and carbon dioxide, which is made from the hydrogen of the acids and the carbonate from the sodium carbonate. Left behind is sodium ion and the sulfate ion. Identify their charges to find the to make the formula of the salt and then balance the equation. So water and carbon dioxide form. So we are left with the sodium ion, which is a +1 charge, and sulfate ion, which is a -2 charge. Yes, Manahil, can you tell me the formula of sodium sulfate, the salt? Sodium is +1 and sulfate is -2. Na2SO4. Now, if you look at the state symbols, now sulfate is aqueous on both the sides, right? And sodium is ion is also aqueous on both the sides. So whenever we are going to make the ionic equation, this and this are going to be cancelled out from both the sides, because sodium and sulfate both are aqueous now. So we are left with the hydrogen ion and a carbonate ion on the left hand side, which are turning into water and carbon dioxide. So this will be our ionic equation.
The charge of CO3 is 1 negative 1, right?
2 minus.
CO.
Yeah. So this is how we will make the normal equation and the ionic equation. Now do the equation of phosphoric acid and magnesium carbonate as well.
Fourth one.
Yeah.
Sodium sulfate formula.
Na2SO4. Okay, if I ask you, look at the equation 3 and tell me what will be the observation.
The colorless bubble gases.
Bubbles of colorless gas, because both the reactants are aqueous, and in the products we have aqueous, liquid and gas. So gas, whenever the gas is formed in the solution in aqueous, along with the aqueous we always observe a bubbles. Okay, now if you look at equation 4, what will be the observation?
Solid metal.
Solid, it's not metal, it's a compound, right? It's metal carbonate. So you just write solid disappears and bubbles of a colorless gas. Both for equation 4, equation 1, equation 2 and equation 1. For all these 4 cases, there are 2 observations because the metal carbonate is solid. So solid disappears and bubbles of the colorless gas. And for equation 3, there is observation that bubbles of a colorless gas only because there is no solid on the reactant side. Okay. Beside this, is there any other observation?
The beaker
Very good.
gets warmer.
Beaker gets warmer because these reactions, the reactions of acids are always exothermic. Okay. And we are getting a carbon dioxide gas. So what will be the test for a carbon dioxide gas?
Lime water.
We will pass the gas through lime water. That is the test. And what will be the observation? It turns milky. Okay. So note down the observation and test of carbon dioxide. Everybody completed the previous equation? Okay. Is everybody done? Okay, now we have a reaction of bases. One reaction of a basis with the acid that we already did. Then when base and acid reacts, we always get salt and water. Okay, besides this, the base also reacts with ammonium salts. So when base reacts with ammonium salts, we always get another salt which doesn't contain ammonium, because that ammonium ion liberates as ammonia gas and water is formed. So this is our general equation for this reaction, that whenever a base reacts with the ammonium salt, a new salt is formed. Along with that, water and ammonia gas is formed. Okay, so complete this, then we will see how to make these equations and their ionic one. Is everybody done till here? So if you look over here, this is a base, a metal hydroxide, and it is reacting with ammonium salt. So as we discussed earlier, what we are going to get? Water and ammonia. It's not carbonate. In carbonate, we will get water and carbonate. So we will be getting water and ammonia. Okay. So if we see, this water and ammonia is formed from these ammonium ion and this OH. This OH and these ammonium ion are basically forming water and ammonia. So what is left behind? Sodium,
Sodium.
which have a +1 charge, and phosphate PO4, which have a 3- charge. So by the help of these charges, we are able to make the formula of the salt that is formed, which is going to be Na3PO4. Is this clear? Now, balancing the equation. How many sodium are here in the salt? 3. And here we have only 1. So we will put a 3 over here. How many ammonium are over here? Yes? 3. So they are going to form 3 ammonia molecule. Okay, so as 3 hydroxides are formed, so they are going to form 3 moles of water. So we'll put a 3 before H2O. Now the equation is balanced. If you see over here, 1 Na, sorry, 3 Na, 3 Na, 3 OH, okay, 3, 3, 3, and here we got 3 and 12 hydrogen. So if you see in total, we have how many hydrogen? 15 hydrogens and 1 phosphorus, and how many oxygens? 4, and 4 and 3, 7. So if you see 3 sodium, 1 oxygen, sorry, 1 phosphorus, 4 oxygen, 6 hydrogen, 3 oxygen. So see 4 plus 3, 7 oxygens, 3 nitrogen, and 3 threes are 9. So this 9, and where are these? 9 and 6 makes it 15. So see, there are 15 hydrogens on both sides, 3 nitrogen on both sides, 7 oxygens on both sides, 1 phosphorus on both sides, and 3 sodium on both sides. So the equation is balanced now. So to make the ionic equation, we will do the same thing. We will split the aqueous substances into ions, then remove the ions which are same on both the sides, and rewrite the equation. So we will get the ionic equation over here.
सर वो 3OH नेगेटिव नहीं होगा?
The thing is, if you see how many OH are here, how many ammonium are here, how many water are here, and how many ammonia are here, all are 3, 3, 3. So it can be simplified to 1, 1, 1, 1. If they are in different ratio, then we keep that the same thing. But if all are having the same coefficient, so we will simplify it to 1:1 ratio. Is this clear? Yes, Manahil? Yes, Rohan? Yes, Laiba? Yes, Aisha and Khatija? Okay, now
Yes.
complete this equation and then make the ionic equation from this one. Let me zoom. Barium is in group 2. Yes, Manahil, are you done? Ruhail. Okay. So as we know, the two things are H2O and ammonia. So we are left with the barium ion and a phosphate ion. Barium is 2 plus and phosphate is 3 minus. So what will be the formula of the salt?
3BaPO4
Ba 3 PO4 twice. And if we balance the equation now, as there are 3 Ba, so I'm going to put a 3 over here, and 2 phosphate, so I'm going to put 2 over here. So that makes 6 ammonia and 6 water. And that will be the ionic equation. Now you can see the rest of the equations as well. So complete these equations, and if you have any doubt in any of the equation, please ask. The pink one or the ionic one. आप बताएं अगर कोई कंफ्यूजन हो समझ में आ गई किस तरह और आने की आपको ठीक है ये कंप्लीट कर लो. Yes, Khatija and Aisha Osman Ghani, if you guys have any problem, please ask.
No, sir, it's clear.
Okay.
इस इक्वेशन में भी 6 कॉमन है तो कैंसिल आउट हो जाएगा.
Yes, because all are 6, 6, 6, 6, 6. So that's why if you see, I put 1, 1, 1, 1.
पेपर में तो नहीं कैंसिल आउट.
Yeah, you can. Aisha, remind me after the class, so I will share the recordings. Okay, in the evening. Done. Yes, everybody completed? Yes, are you done? Okay. Yeah.
Nitrate के साथ -1
-1. NO3 -1, Cl -1, SO4 2 minus, PO4 3 minus. Yeah, Aisha and Khadija, if you guys are done, you can leave. You guys also can leave if you are done.
but carbonate is negative.
2 negative, yes, carbonate is 2 negative. Allah Hafiz.
That was it.
Allah Hafiz.